Coming from you. All right, so, you're always asking me about the application, and you're right. I guess if you're a piano tuner, and we have a piano, and I've talked to our piano tuner quite a bit about the mathematics in music. And those of you who are musicians would certainly appreciate this. So sometimes I try to find word problems that I thought will appeal to different people. And in this case, members of the symphony orchestras traditionally tune their instruments to the note of concert A, which has a frequency of 440 vibrations per second, and that's measured in what? Hertz, okay? And notes an octave apart, and what do we mean by an octave?
The same note.
Okay, the same note, only higher, okay? Sounds similar, but the higher note has twice the frequency of the lower. So give the frequencies of the notes one octave above and one octave below concert A. So what did you get for an octave above it? 880, okay, because it is twice, and then one octave below it is going to be 220. Okay, was everybody okay with that? That was pretty straightforward. All right, then let's read the next part. All right, there are 12 intervals in an octave. So on a keyboard, and I really don't know about a saxophone, how those are played, but on a keyboard, what, do you want to tell us? Pardon me?
Yes. You want to know?
Yeah, I'd love to know.
When you play the notes by closing the pads.
Okay, the pads, but you know how on a piano, it's very easy to visualize because you have
Oh, you want to know what the notes are?
all the keys, or you have the black, keys, I guess, and they're easier to see, but for
What are you
me,
What it does is you blow into the reed vibrates, and by basically closing the valves, you lengthen or shorten the instrument to make the sound higher or lower.
okay,
So to make a C, you gotta get your middle finger, or D, so it's basically just going from one octave, you change your fingers to make the instrument longer or shorter. Just so the wing comes out. So instead of coming out, it just comes out that first hole. It comes out. If you're playing a low A sharp, which is the lowest note, comes straight out.
huh. So it's, that's, mathematically, that's really very interesting when you think about the A on a saxophone. Obviously it has a different tonal quality, being the same as, and that's if you go to a concert, you hear them all trying to adjust and get into tune together. So it's very interesting. Okay, Brad?
What would the relationship between hertz?
Okay, hold on, I want to hear a question. What?
What would the relationship between hertz and megahertz be? Would it be 1,000 hertz? Would be
I would guess that. I don't know the answer to that. Anybody know the answer to that question? Repeat your question. Gentlemen.
How many hertz to a megahertz? Or the other way around?
1,000 mega. It sounds like that
1,000
word.
hertz and a megahertz.
No, megahertz.
Right, mega being the prefix.
Yeah.
Right. Good.
All right.
Good. Next conversation. Okay, so let's look at this one. So there are 12 intervals in an octave. So the frequency of each note is the 12th root of 2. Okay, think about that. Is that a pretty small number? The 12th root of 2 times the frequency of the next lower one. So what would A sharp be? What did you say it was?
About 466.
About 466.2. Okay?
Yeah,
So,
lots of-
can I multiply? Is this a number? It's a small number. And, maybe we don't know what that looks like, but can I read? This just says, so the frequency of each note is this times that. So I need to do what? 440 times 12 rad 2. Can I rewrite 12 rad 2, the index? Yeah, I can write this as 2 to the 112. So do that in your calculator and tell me what you get.
1.05946.
So that's how many, just
That's
to the nearest,
32.
let's go to the nearest
That's
one.
not multiplied. Oh, wait, never mind.
1 point what?
That's
1.05 is this times that. So what is the frequency?
Wait, how do you do that?
Can I do,
Oh, I
is
have to do it.
this equal to this? Okay, can I enter this into my calculator?
Yes.
Okay, I can enter this in, and I'm gonna show you another way. 12 caret, parentheses 1 over 12. And what it, I'm sorry, it wasn't 12, it was a 2. And what is that number? 1.06. Okay, so what is the next one? Would it be 440.2?
466.
Yeah.
66.
For what?
466.
466, sorry. 0.2. Yes, ma'am.
Okay.
Yes.
So this is when I see these up,
Okay.
right?
Okay, so does that answer your question? And then I would do that again and again and again.
I didn't put together to put the 12 and then the red 2 as 2 times 1 over 12.
Doesn't that make it a lot easier to deal with?
Yeah, I didn't think of that.
Okay. All right, all right, so that takes care of 35. Anybody else have any questions on 35? Okay, how about 61? Okay, so everybody take out your calculators and let's look at what this says. Okay, so it says use a graphing calculator to graph these. Now, before, and how are we going to enter these into the calculator? Anybody? So, would you agree with this statement, that this is, geez, I can't write today. That this is equal to what? X to the
Okay.
1/2. And the next one is X, and I think it goes 4, and it goes up to 5, right? I want you to think.
Yes.
Which of these is going to be the smallest number? X to the 1/5. Think you're taking the 5th root of that number, so it's going to be pretty small. So in this, now I looked at this, and they're telling you the X values range from 0 to 2, and the Y values range from 0 to 1/2. And if you enter them then into your calculator, let's take a peek. All right, and I did this for you. I want to show you what I used for my window, because that's pretty helpful. They told me that the X values range from 0 to 2. And I kind of like to look at, well, what happens at the at 0. And you see how they bunched it up here? And I don't like that. So I try to see, well, I want to just see kind of what it looks like. And I also try to include some of the Y values right there so I can see it. And to me, so just if you care to know, I did X was a -1, and I did a max of 3, and an X scale of 0.5, and then a Y minimum. Again, I just want to see right below the X axis. So I have a -1, a maximum of 2, Y scale of 0.5. And I think it just helps to see the window a little bit. Is that okay? Can I move off of this? Okay. And so when I graph it, it's like, wow, isn't that cool? Right? Now, my question is, they're asking you to identify them. So we had said that my X scale was going to be what? 0.5. So here's my 1,